All right, class, next section in our unit is 3.6. Going to skip over 3.4 and 5, do 3.6, and then go back and do 3.4 and 5. It just makes a little bit more sense to do this one first. And we're going to be proving theorems about perpendicular lines. Theorem 3.8. If two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. So we have two lines that intersect to form a linear pair of congruent angles. So here's our linear pair. We have two congruent angles, 1 and 2. Then we know the lines are perpendicular, because if they're congruent, they both have to be 90 degrees. Because they're a linear pair, that's supplementary. 180 divided by 2, 90 degrees. So angle 1 is congruent to angle 2, then G is congruent to H. Theorem 3.9 states if two lines are perpendicular, then they intersect to form 4 right angles. So we have two lines that intersect. They will form 4 right angles if we know that they're perpendicular. So we know they're perpendicular, then they will intersect to form 4 right angles. 1, 2, 3, and 4, all 4 right angles, all 4 90 degrees. That is only when those two lines are perpendicular. Theorem 3.10 states if two sides of two adjacent acute angles are perpendicular, then the angles are complementary. So we have saying that the two sides are perpendicular. We're talking about AB being the side of angle 1 and BC being the side of angle 2, and we see 1 and 2 are adjacent. They are side by side and touching. Then they're going to be complementary. So we know that larger angle of ABC is 90 degrees, and we know 1 and 2 are congruent because it's split, or not congruent, but because they're split within that 90 degrees, they have to add up to 90 degrees. So they might be a 45-45, or they might both be 45, or they could be different angles, measures, as long as they add up to 90. Theorem 3.11 states, if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other. So if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other. So if H is parallel to K and J is perpendicular to H, we see that there, that it's a 90-degree angle, then J is also perpendicular to K. That's what we're saying there. So then, again, that only deals with H and K being parallel. Theorem 3.12, lines perpendicular to a transversal theorem, states in a plane, let's get this up a little. In a plane, if two lines are perpendicular, to the same line, then they are parallel to each other. They are parallel to each other. So what's saying down here at the bottom, if M is perpendicular to P, P and M are perpendicular, then M and N, and N and P are perpendicular. Then we know M and N are parallel. So if in a plane, two lines are perpendicular to the same line, so M and N are both perpendicular to line P, then they are parallel to each other, meaning they will never cross. So let's apply that knowledge to these examples. We need to find the value of x. So example A, we need to find the value of x. All we have on there is an x, and that little symbol there showing that that angle is 90 degrees. So if we know that's 90 degrees, we know x has to be 90 degrees because they're vertical angles. So x equals 90 degrees. Then looking at B, we see that this angle out here on the side is 90 degrees. So that means that 62 and x have to add together to be 90 degrees. Because we know if one side of a linear pair is 90, the other side of the linear pair is going to be 90. And 62 and x are that other side. So that's also 90 degrees there. So 62 plus x equals 90 because 62 and x are complementary. X will equal 28. All right, next we have the distance between two parallel lines. We need to find the length of a perpendicular segment from one line to the other. Distance between two parallel lines, find the length of a perpendicular segment from one line to the other. So we're talking distance between two parallel lines. We're looking at EF and CD. And then distance from a point to a line is the length of the perpendicular segment from the point to the line, the shortest distance from the point to the line. And we got that image down here at the bottom. Right there. Point A to point B would be that shortest distance from the point to the line. And we're wanting to find that distance. We also need to think back to the slope formula. So you remember the slope formula? Well, a slope, for starters, is your rise over run, right? And to get rise over run, you do y2 minus y1 over x2 minus x1. Your y is subtracted over your x is subtracted. And so our slope formula is m equals y2 minus y1 over x2 minus x1. m being the slope. And just remember, slope is rise over run. Slopes of perpendicular lines have opposite reciprocal slopes. And opposite reciprocal slopes. So what are opposite reciprocals? If one slope is, let's say, 3 over 4, the opposite reciprocal of that, opposite meaning opposite sign, so we know it has to be negative, and the reciprocal is flipping the position of top and bottom. That would be the opposite reciprocal of 3/4, would be negative 4/3. Or if we had a slope of 2, the opposite reciprocal of that would be negative 1/2. We would have to make a negative opposite sign and flip the fraction to make it 2. Or 1 over 2. So change the sign. If it's negative, it becomes positive. And flip the fraction. And if it's a single number like 2, turn it into a fraction, because remember 2 is 2 over 1. So it becomes 1 over 2 and negative. So that's your opposite reciprocal. And that is going to be slopes of your perpendicular lines. So if we need to find the distance between two parallel lines, the section of broad gauge railroad track at the right are drawn on a graph where units are measured in inches. What is the width of the track? So all of these units, those are inches, but we've got so point 29 and 74. Point Q is at 71.34. Point R at 91.55. And we need to find the distance or the width right there. So we want to find that. So we need which segment is perpendicular and what points do I use? So if it's a railroad track, we know that the rails are perpendicular, or parallel, sorry, not perpendicular. We know that they're parallel. So all of these cross sections are going to be perpendicular with it. So from P to Q is going to be our perpendicular, or it's going to be our segment, PQ. Which segment is perpendicular? It's PQ. And those are also the points that we want to use. So we're going to use 29.74 for P and 71.34 for Q. And we need to use the distance formula. So we're going to write this into our notes also. Remember our distance formula. That is D equals square root x2 minus x1 in parentheses squared plus y2 minus y1 in parentheses squared. So we need to plug in our numbers from P and Q into our distance formula. Big long square root sign. Take our x's of 29 and 71. We're going to subtract them from one another. 71 minus 29 squared. So I've identified Q as my x2, so I need to use Q's value for my y2, which is 34 minus 74, and that'll be squared. So subtract those and then square them, and we get 1,764 plus 1,600. So that's added together 3,364. Square root of that, if you punch it into your calculator, actually comes out to be 58. And we're told we're dealing in inches. So 58 inches. All right, last example. We need to find the distance between the two lines. So we've got our two lines drawn out here with their points. A point at -2, 0. Point at 1, 1. And a point at 2, -2. We need the distance between the two lines. So we want the shortest distance possible, right? We need a perpendicular line. So to know it's perpendicular, we've got to find, it looks like we should use this, but we also need to prove that that slope is the opposite reciprocal, right? So let's look at our slope of our blue line here. So slope of the blue line, we go up 1 over 3. Use a different color, so we're going up 1 over 3. So that's the slope of 1 over 3, rise over run. And then the slope of our other line needs to be the opposite reciprocal of that. And we can look at it from between 1, 1 and 2, -2. From 1, 1, we go down 3, and to the right 1. So that would be m equals -3 over 1. So it's opposite, and it is the reciprocal. So this is a perpendicular line. So we're going to use the blue line there. So we need the distance formula from those 2 points, -2, 0 and 1, 1. So if I draw out our distance formula, 1 minus -2 all squared plus 0 or 1, so I started with the ones, 1 minus 0 squared, 1 minus -2 is really just 1 plus 2, so 1 plus 2 is 3, squared is 9, and 1 minus 0 is 1, and squared is 1. So that equals the square root of 10, which is about 3.16. All right, that's it for the notes. Make sure you do your homework.